Hi, welcome back to our new session. Last time we had seen was the frequency distribution table, right? That was the one we had seen, and some basic part, right? How to find out the class boundaries, how to find the midpoints, how to find the width from a class, right? The example we had seen was the IQ scores for the low-let group. Right, the frequency pretty much just telling us how many people fall in those group. Right, for instance, 50 to 69, 70 to 89. To 109, 110 to 129, and 130 to 149. Right, that is the given table, right, for the IQ scores and frequency. What also we had said was the group on the left, right, the lower limit, basically it is the lower class limit, right, of the lower bound, lower limit actually. Then the higher value 69, 89, 109 and so on, that's our upper class limit. So any data falling between the IQ score of 50 to 69, that's falling this first group. Right, for the second group, taking all the values from 70 to 89, that's for the IQ scores and so on. The frequency means out of that many people or many children we observe, right? Two kids falls in the range of IQ score between 50 to 69. Right, that 7 of the kids fall in the range of IQ score have 110 to 129, right, and so on. That's what it means. Then in order to find the class boundaries, the class midpoint and class width. Well, we had a shortcut of formula say before, right? To find the class boundaries, that lower bound is the 1/2 less than the lower limit. Upper bound, lower class boundary will be limit minus 0.5, and the upper class boundary will be the upper class limit plus 0.5. And the class midpoint is either take lower class limit plus upper class limit divided by 2, right? And the class width, that is 2 consecutive lower class limits or 2 consecutive upper class limits. Right, which we can see that, well, the class boundary, the first one we get is 50 minus 49.5, minus 0.5 is 49.5. The upper boundary is 69.5. Which we can see that this 49.5 is simply 50 minus 0.5. And this one, 69.5 is 69 plus 0.5. Right, for the calculation we do for the lower and upper limits. Right, then the next one will be 69.5 to 89.5. 89.5 to 109.5. that we can see is, well, the boundaries are connected with no gaps, right? That we get the jump from 49.5 to 69.5, then 69.5 to the next 89.5, then from 89.5 to 109.5, and so on. That we get is the boundaries. Of course, it only applies when the gap between two classes is 1, and for our course here, we only will see is the gap between the two classes 1, right? Maybe for some other courses, we'll see the gap between two classes is not 1, then the scale using differently, right? Then it will be do a little different. But anyhow, now we have the class midpoint, that's 50 and 69. The middle is what? That is 60.5, maybe. Let's see. 50 plus 69 divided by 2, that's 59.5. And then we do similarly adding the two of the next class, right? 70 plus 89, then divided by 2, that's 159 divided by 2, which is 79.5. Then what we'll get is similarly adds down 9 divided by 2, right? 99.5, 119.5, and 139.5, if you follow this formula. And the class width, what we're doing is the difference between two consecutive lower or upper limit, right? That we get the difference is 20. 70 minus 50 is 20, 89 minus 69 is 20, then the class width should be equally length, right? Should be equal length. Then the next class and following every class has a width of 20, right? Even though another thing we can observe is the difference between the class midpoint should also be the width. Also, the difference between the boundaries should be the class width as well. Even the difference between each class boundary is class width. Right, so once we find the class width, it should be fixed for every class. So every class should have the same boundary. Should have the same width. Right, so that's how we apply those formulas, right, to find the boundary, midpoint, and class width. Right, so if we do similar example of age of years of best actor, to win the Oscar reward, best actor. The frequency provided in the table, and to us find the class boundaries, to find class midpoint, which we can use the class midpoint and the class width. Right, the notation for class midpoint, we can use x sub m. The notation for the class width, as seen, we could just use w to make it stand for class width. Right, and we have data from 20 to 29. $30, $40, t. Right, 70 to 79. That's the age range, right, for the Oscar batch detector. Right, we have frequency from the table. That's one person got it in his age between 20 to 29, 26 people and 35 for their age at 30 years and the age at 40 years, and 13 and 6 and 1. Right, so that is the frequency distribution we have. Then from that frequency distribution, we want to find the class boundaries, class midpoint, and class width. Right, class boundary, which if you remember the formula, right, minus 0.5 from the lower bound, right, 39.5. And for the upper class, we add 0.5 to it. That's 29.5, 39.5, 49.5, to 69.5, to 79.5. Right, that we add 0.5 to the upper boundary, upper limit to get upper class boundary. Right, that's for class boundaries. And then class midpoint, we do is add all them together, then divide by 2, which is the middle between 20 and 29, which is 24.5. Right, how we get is lower class bound. Bound the same, we use limit as usual. Upper class limit, then divide by 2. Right, then we get 34.5. 44.5, 54.5, 64.5, 74.5. Right, again, we use the fact that the gap should be the width. Right, so if we check that, well, the gap should be 10 in each class, then we could use the fact to double check our result. Right, if we get the gap between the boundaries is the width, if the gap between the two consecutive lower or upper boundaries are the width, right? Or the gap between the two class midpoint is the width unknown, right? That is the thing we can double check our work, right? To make sure that we're doing the right thing, right? If we do it rightly, the gap between the class boundaries, class limits of two consecutive one, as I marked, labeled those two consecutive upper or lower boundaries, should be also the width. Right, even the gap between the two lower and upper boundaries should be the width, and also the gap between the midpoints should be the width as well. Right, everything should agree with the class width of what it's supposed to be. Right. That is also another example we can see, right, to find out the class boundaries and midpoint and so on. Right. We use them to draw a conclusion of a graph right later on. But before, let's see if we get from an individual data how to construct. how to construct a frequency distribution, basically it refers to construct a table. I decide number of classes. We give individual data basically, right? So first of all, decide number of classes. Usually we decide between 5 to classes to 20 classes, and sometimes if we do a question, it will be given. And sometimes it's given. Alright, the second one is calculate the width. Right, the class width, it should be the maximum value minus the minimum value divided by number of classes. And always round up. So no matter what we get, always will be round up or round to the next integer. That's what round up means. If we get in case calculate out to be 2.1, it will become 3. If we get a 5.8, it will definitely become a 6. Even though if it's a whole number 9, that will become the next integer 10. And no matter what, we always round to the next integer. It's not only round up, but rounds to the next integer. Even though it is an integer, but we round to the next integer. Right? That's the way we round it. Right? In order to cover every data in the data set. Right? Sometimes it may not. Right? If we don't round up, if we get a whole number, it will not cover every data from the data set. Right? So always round up. Right, the third one is pick the starting point. Which is the first lower class limit. Use the minima value or the convenient value below the minimum. Usually what we just do is pick the minimum value as the starting point, which is the starting point refers to the first lower class limit. Right, then the next one is the use the starting point and the class width to list all of the lower class limits. Right, then as the gap between two classes is 1, then we get list the upper class limits. Use the fact that the gap we just use the fact that to make the gap between the two classes is 1. To make the gap to be 1, then if we have all the lower class limits, then we have the upper class limit. Then if we list every upper class limit, we could use the width as well, right? Or we could use just the get by one to list everything. Then the last one is tab. Right, then the class was built. We just need the frequency, which we need to tally the data and count the data value, how many of them fall in each class after we finish tallying. If I tally the data. That we use the tally, we'll see some technique how to use the tally. Right? If the data is well ordered from minima to maxima or from maxima to minima, right? That's, in other words, monotonically, that is fine. But if it's not monotonic, it's jump back and forth, then it's better to have a new technique, right? Because it will happen in some way that we may skip something. Well, that's the way how we do them, the steps. And let's see the example, right? How to construct it. Actually, what these steps doing. Let's see the example. Then maybe we could have the better understanding, right? What we should do. Construct. Right, the data set construct with frequency distribution with 4 classes. Right, that we have the data 82, 93, 85, 75, 85, 80, 101, 89, 80, and 94, 88, 104, 88, 88, 83, 104, 96, 76, 80, 89, and then 75. That's in total is 21 data set, 21 data, right? 21 input values. Then we can see, well, the largest kind of one we observe, we get two of the 104 is to be the largest value, nothing bigger than 104, right? And the smallest value, we can see 2 of the 75s are the smallest. 104 is the largest, and 75 is the smallest. Therefore, the first step is to find out the class width. If you have the steps together, right? The first is we have 4 classes given in the question. Right, then to calculate the class width, that's the maximum value minus the minima divided by 4 classes. Alright, then we subtract 104 minus 75 is 29 divided by 4, 7.25. Always round up for the class width, we get the width to be 8. Right, then we can construct the table. Right, then we can construct the table. Class. Then we tally at the end. We'll get frequency. Right, the class, how we build it, right, that's separated into 1, 2, 3, and 4 classes. By building to 4 classes, right, for the class. Right, and the next step saying, well, to put the starting point. The starting point, if it's the lowest value 75 is good enough, then use the width plus 8, that's 83, okay. Plus 8 to be 91, then plus another 8, that's 99. Right, the gap between them is the class width, right, for the consecutive lower class limits. Right, then for the upper class limits, that use the fact that we use the gap to be 1, that's 82, then the one less than that, and the last one we can see also the gap between them is the class width, that we can add 8 to it, that's 106. Right, so if we count the number of data in each class, right, directly without tally, well, we will count, well, from 72 to 80, 75 to 82, we get 1 value, 2 value, 3, 4, 5, 6, 7, 8, right, 8 of them. Then we write it down. The thing is, well, we may skip something, or we may make some mistake, right? For some number not belong to this class, we may accidentally put it into the class which is not belong to, right? Which this one doesn't belong to. So what we do is we tally, which we go just forward into the class once, into the data once, and we find out which this data it belongs to. Right, for example, we have 82, that belongs to our first class. 93 here is belong to our third class. And 85 is second class, and so on. Right? We're going through all the data once, that everything is being counted and nothing missing, not to miss anything. 75, 85. That we have 5 data done. Right, then 80, 101 is in the last class, 89 is in the second class, 80 is in the first one, and 94. Right, 94 is in the third one. Right, then 88 in our second class, 104 in our last class, 88 second, 5 together, right? 88, another 88. 83 is in the second class. 104 is in the last class. 96 in the third class, right? Then 76 in our first class, 80 in the first class, 79 and 75 both in the first class. Like that, we can count just about what we get from tally, right? To see that frequency, well, that's 5 is as a group, then that's 3 more, that's 8, 5 and 2, that's 7, and 3 and 3. Right, so that's our frequency table we built. Right, just beside the tally, we get the frequency and the class as the lower and upper limits we found, and we found the frequency of each one. Right, so we actually construct the individual data into the grouped frequency distribution. Right, that's what we do. The next thing we need to find out is the relative frequency. And the relative frequency, for example, the low let group. IQ scores as the classes. The frequency, we can just use the notation of F. Right, for the frequency given, I still 2, 33, 35, 7, and 1. But for relative frequency, is frequency related to total, right? The relative frequency, we need to find how many data set we have, right? How many data in the data set, which is 78. So to get the relative frequency, we just, not only the frequency we take, but we take it into a relative result. In other words, we take it into percentage, right? How much percent is this frequency is related to the total. Right, so what we do is divide 2 by 78 and convert that into a percentage. Right, 2 divided by 78, that is 0.02564 and so on. If we keep 1 or 2 digits decimal, right, if we keep 1 digit, that's 2.6%. Right, from decimal to percentage, that's keep 2 digits to the right. Right, then the next one is 33 over 78. Convert to decimal and go to fraction. Go to percent. Right, 22.3. And similarly, divide 35 by 78. That's 44.9%. 9.0% for the next, and 1.3%. Right. That is similarly just divide the frequency by the total and convert into percentage. Right, that's how we do the relative frequency distribution. For example, I try to do the example that for a cigarette continue level, that for in range of continuing level, that's the number of smokers basically take. Right, the number of smokers, that's 11, 12, 14, 1, and 2. We need to find the relative frequency. First of all, by adding all the smokers together, we find out, well, it is 40 smokers we observed. Right, that's 40 smokers we have. Then the relative frequency is nothing else but just divide 11 by 40 and convert that into percentage, and 12 over 40 and convert that into percentage. 14 divided by 40 and convert it to percentage, that's 35%. .5% and 2 of them basically is just 5%. So if we divide and multiply by 100, right, converts the fraction into decimal. Right, so relative frequency basically is just the percentage. Right, converts each frequency to total that is as a percent. Right, convert as relative frequency.